my screen. And okay, so radicals. A radical is literally this symbol here. So if there's not a number written up there, it's an understood 2, which would be a square root, but that tells how many identical factors you're looking for. So if this was a 3, you would be looking for 3 identical factors, but we're talking about square roots and perfect squares. So a perfect square is a number with whole number square roots. So if you typed it into the calculator, square root of 25, the answer would be 5. So that 25 is a perfect square. If you typed in square root of 26, it would give you a decimal. So that is not a perfect square. There are 2 ways that we deal with radicals. One way is by evaluating. That's when you type it into the calculator and you round your answer to the nearest hundredth. The other way is simplifying, which still leaves an exact amount. It doesn't involve any rounding. We're going to be doing simplification. So none of your answers are going to be rounded unless it's a word problem and it asks you to round. But perfect squares are what's going to be the key to being able to simplify these. And the perfect squares, 1 to 100, there are infinitely many perfect squares. 400 is a perfect square, but these first, the 1 to 100, will help you the majority of the time. So the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And we know all of these. You guys have, I don't know how long y'all have done square roots, but most of the time whenever, in algebra, if I say what's the square root of 81, most of you know it. Those are all perfect squares, but as you can see, like there are lots of numbers between these, like square root of 2 is somewhere in there, square root of 3 is somewhere between these two, square root of 20 is somewhere in between square root of 16 and square root of 25. So any number that's not in this list between 1 and 100 is not a perfect square, but might be able to be simplified using the perfect squares. The steps that we're going to do is we're going to look for the biggest perfect square. Divides evenly into the number. Then what we're going to do is we're going to rewrite the number as the product of the perfect square and what's left. Then the last thing is we're going to square root what we can. And that comes outside the radical. So we're going to square root what we can, and then we're going to leave the rest under the radical. So and technically that step, all of these steps can be done in your head. Eventually you'll be able to do them in your head, or you'll have the perfect squares or have the simplified radicals memorized. But let's look at these first examples. Okay, so example 1, you can see that square root of 8, it's not in this list of perfect squares over here. It's somewhere between square root of 4 and square root of 9. So we know it's going to be, if we evaluate it, if we typed it into the calculator, it'd be between 2 and 3. It'd be 2 point something. But we want to simplify it, meaning we want it to be still exact. So by the steps, we're going to look at this list of perfect squares, and we're going to find the biggest one of those that'll divide evenly in 8. And if we're looking for the biggest one, the first thing you can know is it's not going to be bigger than that number. It's not going to be bigger than 8. In example 2, the biggest perfect square that goes into 50 is not going to be bigger than 50. But square root of 8, the biggest perfect square that'll divide evenly in 8 is 4. So I'm going to rewrite 8 as that 4 times whatever is left, which is 2, 4 times 2. So we're rewriting it as a product. Now, the perfect square is the one that I can square root. So I always underline the one that I can square root. I can square root 4, and it comes out as I square root it. The square root of 4 is 2, and this 2 here that I'm circling my cursor around stays underneath the radical. So square root of 8 and 2 square root of 2 are equivalent. That means they're the same, they're worth the same value. So if I type square root of 8 into my calculator, that is about 2.83. I can do the same thing here. That literally means 2 times the square root of 2. So 2 times square root 2. That's exactly the same thing. It's about 2.83, and it's the exact same decimal. So what we've done is we've just rewritten it in simplified form. That's going to help us be able to combine radicals and stuff like that. Okay, so let's look at example 2. Square root of 50. Again, 50 is not in this list over here. It's somewhere between square root of 49 and square root of 64. But by the steps, I need to see if there's a perfect square that will divide evenly into 50, and I want the biggest one. So my the biggest perfect square that divides into 50 is 25. So I'm going to rewrite 50 as 25 times 2. And if you wrote it as 2 times 25, that's the same thing, because the only thing under there right now that can be square rooted is that 25. And when I square root it, it comes out. The square root of 25 is 5. And this 2 here stays underneath the radical. So number 3, okay, 200 is bigger than this whole list, but since I want the biggest perfect square, I'm going to start. I want to work my way back this way, because I might, if I worked my way forward, 4 goes into 200, but it's not the biggest number that goes into 200. 25 also goes into 200, but it's not the biggest perfect square that goes into 200. 100 is the biggest perfect square that goes into 200. So I'm going to rewrite 200 as 100 times 2, because then I can square root 100, which is 10, and that leaves 2 under the radical. Okay, so number 4, same thing. 12 is not in the list, but I can rewrite 12 as 4 times 3. I can square root the 4. Remember, when you square root it, that number comes out, the 2 comes out, the 3 stays underneath. The 2 is the square root of 4. Now, always choose square root of 32 and the square root of 72 to show you that looking for the biggest perfect square that goes into a number it just makes the simplification easier. You can pick any perfect square that goes into that number. You just might have to simplify again. I'm going to show you first picking out the biggest perfect square that goes into 32. which is 16. Square root the 16, the 4 comes out, the 2 stays underneath. However, 32, a lot of people, the first thing they think of is 4 goes into 32, which is correct. I can do that, square root the 4, so I have 2 square root of 8. Now look, this over here is simplified, perfectly simplified. This one, 2 square root of 8, can be done again because 8 can be rewritten as 4 times 2. This 2 comes down because technically that's multiplying by the square root of 8. Then I would square root that 4. And I'd still end up with 4 square root of 2, which is the same thing. It just took a little bit longer. Now, sometimes multiple simplifying, you'll probably have to do that because if your number is really big that you have to simplify. So 72 is the same. 72 is 9 times 8, but you'd have to simplify it twice in order to get it fully simplified. So 72, I can write it as 36 times 2, square root the 36, so you get 6 square root of 2. Okay, so 225, let's say you don't know that 225 is a perfect square. The way you can see if a number is already a perfect square is type it into your calculator. If I typed in square root of 225, it would tell me 15. But let's say I didn't know that, but I did know that 25 goes into 225 and it goes in 9 times. You can see 25 is a perfect square, but so is 9. That means both of them can be square rooted. The square root of 25 is 5. The square root of 9 is 3. Since I ended up with a whole number that doesn't have a radical with it, that means that it was actually a perfect square to begin with. So if I had typed it into my calculator, square root of 225, the calculator would have given me 15. Now if you look, number 8 has variables. So we're going to go up here real quick. We're going to talk about variables. Okay, variables, if they have an even exponent, they're already a perfect square. So x to the 4th, if I square rooted it, that's x squared, because x squared times x squared is x to the 4th. If I square rooted y to the 8th, that's y to the 4th, because y to the 4th times y to the 4th is y to the 8th, because you add the exponents. So the way you square root a variable with an even exponent is you half the exponent. If your expression has a variable with an odd exponents are perfect with one extra. So if I'm talking about the square root of x to the 7th, I can rewrite that as the square root of x to the 6th times x. That x to the 6th is my biggest perfect square that will divide evenly into x to the 7th. That one I can square root, which means I would have to half that exponent and the other stays underneath. So let's look at some examples of that one. Look at number 8 here. Okay, so 16 is a perfect square. I'm going to underline it because I don't have to rewrite it as a product of anything. And x squared, since that 2 is an even exponent, it's also a perfect square. I don't have to rewrite it as a product either. So the square root of 16 is 4. The square root of x squared, half of 2 is 1. So the square root of x squared, 16x squared, is 4x. Because if I multiplied 4x times 4x, I would get 16x squared. Number 9. So 9 is a perfect square, But since that x has an odd exponent, that one is not a perfect square. So I do need to rewrite part of this. I don't need to rewrite the 9. I can bring it straight down. X cubed, I could rewrite that as x squared times x. And x squared is perfect square. So now I'm going to square root all the stuff I underlined, and the stuff I don't underline is going to stay under the radical. The square root of 9 is 3. The square root of x squared, half of 2 is 1. And this x here stays underneath the radical because it's left over. Okay. Number 10. All right, so 18 is not a perfect square. It's 9 times 2. X squared is a perfect square. I don't have to rewrite it. And y, even though that's an odd exponent, I can't rewrite it as anything. So what I'm going to underline, I can square root the 9, and I can square root the x squared. So square root of 9 is 3. Square root of x squared, half of 2 is 1. And that 2 and that y stay under the radical. Okay, number 11. 50, I can rewrite as 25 times 2. X cubed, that's an odd exponent, so I need to rewrite it as x squared times x. And y cubed, I'm going to rewrite as y squared times y. Now I'm going to go through and underline everything I can square root. 25 is a perfect square, x squared is a perfect square, and y squared is a perfect square. Those are the only things that I can square root and take out. So the square root of 25 is 5. The square root of x squared is x. The square root of y squared is y. Everything else, a 2, an x, and y, stay underneath the radical. And then number 12. So 45 is 9 times 5. X to the 4th, since that's even, it can just come down as x to the 4th. Y cubed, since that's odd, I need to rewrite that as y squared times y. And then z squared, since that's even, it can just come down as z squared. I'm going to go through and I'm going to underline everything that's a perfect square. 9 is a perfect square, and any variable with an even exponent is a perfect square. I'm going to square root now. Square root of 9 is 3. The square root of x to the 4th, half of 4 is 2, so that's x squared. The square root of y squared is y. Square root of z squared is z. Anything that I didn't square root stays underneath the radical. So the 5 stays under and the y stays under. I need to make that radical that big. How is that, Cade?
That makes sense.
Okay. And so the assignment it only has, I think, 11 problems on it.
Okay.
So, and I think that's all it is practicing that. If it's something different, then I can answer a question.
All right.
So that sounds good?
Yep.